Let me get started. So my name is Lars, and I am a freelance software developer, JavaScript developer. And I also, like Vasil, got interested in Vite half a year ago or something. I've been doing React development for 6 years or something, and have been using Create React app and was very happy with it, especially in the beginning, but felt also it became like things became slow. So I was interested in Vite and started looking into it, and I noticed it was very early days, and I noticed that they didn't really have a good story around testing. So it's true that you can do what Vasil showed, that you can run Jest on your code using TS Jest or something, but it will not use the Vite bundler. So if you use anything Vite specific in your code, then it wouldn't work with necessarily out of the box with Jest, because Jest has its own bundler built into it, and that's not especially fast either. So Jest is not. It's not necessarily a good option. It is an option, but I was looking for a better option where we could like leverage the speed that Vite brings. And I've always been interested in testing. I like having tests for my code, also for my front-end code, using something like testing library or other tools for testing that my code works. So I decided to try to create a good test runner for Vite, and this is what I'm going to show you today. So this is called Mocha Vite Puppeteer. It uses the testing library called Mocha, which is an older but almost as popular and faster testing library. And it uses Puppeteer. So instead of running your tests in JS DOM, which is a restricted set of a browser, it actually runs in a version of Chromium, which is a full browser. So you have access to your various browser APIs in a better way than you have with JS DOM. So there are some benefits in using this combination of tools. So when I thought about how I should do this talk, a little bit like Vasil was saying, how can I demonstrate what you need to do to get up and running? So I'm going to demonstrate how to use Mocha Vite Puppeteer on an existing tool, on an existing project. And instead of using my own project, I went and found and looked for a project that was already using Vite. So you might have, if any of you have ever done anything with Vite, you might know about this resource called Awesome Vite, which is a great collection of a lot of things. So here there are documentation, getting started, templates for various programming languages. And I know this is a React meetup, but one of the nice things about Vite is that it works great with Vue, works great with Svelte, it works with other frameworks as well. And there's a lot of plugins for Vite as well, which is also mentioned on this site. And going further down, there is my little test runner here, which is nice. And if we scroll further down, there is a list of somewhere here of apps being built with Vite. So I went through this list and found one of the projects that is React-based. It's called NPM Vue. So let's take a look at that. So this is just somebody else's project that I'm going to use for demonstration purposes. And NPM Vue is also a funny little project. It's not really that useful, but it allows you to browse files on NPM. Because on NPM, you can only see the packages, but with NPM Vue, you can also look into those packages. So for example, if we look at React, then we can see what are the packages, the files inside the packages. That's what NPM Vue is. I didn't build this. I don't know anything about it. That's how it works. But let's see if we can write some tests for this random project and run them with Mocha Vite Puppeteer. So we will start by cloning the repo, and I have a terminal here for that purpose. So let's just do git clone and cd into npm vue. So this is going to be a live coding session. I hope that's okay with you. This contains the source code and looking, we have to look a little bit on this because, as you can see, it has this pnpm log YAML file. So they're using pnpm, which I had never used before. So this is the same thing as npm or yarn, but it's pnpm. It probably has some benefits I don't know about. But so to work with that, I'm going to write pnpm every time instead of npm, but it's the same thing. So bear with me on that. So we will need to install dependencies. And since this is a Vite project, we can run this project locally after we have installed the dependencies just by running pnpm Vite. So you can see here on the list of dependencies that Vite was included. So this is part of course, of the dependencies for this project. So we can just run it with pnpm Vite, and it will use the default configuration, or actually there might be a specific Vite config file here. And this will give us a dev server running, and we can open the site. Now we are running on localhost, and this is the same thing that we saw hosted on Vercel before. Now it's hosted on my local machine, and I can still it still works. I can look up React and it works. This is what Vite, this is the speed of Vite. This didn't take long, right? This was a React application and up and running this fast. That is nice. That was Basil's talk. Repeat it for you again. So next thing, we would like to add some testing to this. So I'm just going to close this. So let's open up the code and take a little look at what code is in here. And let me also just add my add the tool. So we will do pnpm add save dev mocha Vite puppeteer, and this will download a copy of Chromium. So this will take a little while. So I'll just do this here. So the code for this tool contains some CSX files. This is TypeScript. You also have a little utils, which is a good place to start if you want to write the first test, because here we have some random functions used for this. We need to be able to pass Git URLs apparently. So Git URLs can take many forms, but to look up a project on npm, they need to be able to convert specific URLs to a standardized format. So there's a little function in here called pass Git URL to do that. So let's write a test for that. That should be easy, right? So I will create a new file called utils.test.ts right next to utils. And I have some code lying around, so I don't have to remember to type it correctly. But I will talk about it in a second. So let me just paste this in here. We will get these errors, but I will talk about those in a second. So here I import this function, get repository URL. Oh, that was another one than what I called. That's because pass git URL is actually being called from get repository URL. So I will test the get repository URL function. And we will call it with one of these URLs, and then we will assert that the result is equal to the correct format. So this is a very simple utility function. And I just pasted in my own version of assert equal. We will also fix that in a moment, but for now, let's just keep it like that. So now we have a test for some code. Let's see if we can run that test. So let's go back to the terminal, and we can do pnpm mocha Vite puppeteer. And just like you saw before, Vite has this thing about pre-bundling dependencies. So it will do that the first time around. And thank you. Demo time. So this is our function. This is whatever we wrote in this describe thing here. Describe should translate from Git to HTTPS. This is exactly what it says here, and the test is passing. So we have a running test, so we don't need any more configuration. This works out of the box. That was what I wanted to show you with this. This is not even my code. You can just have a test and run the tool. So Any questions this far? I think I would like to pause and see if anybody has questions. Yes.
So describe the Vite are globally available to your pets, so you don't need for them. Like you just.
Right, and they are also just available for Mocha. So but TypeScript doesn't know about that. So let's fix that. That's what I'm going to talk about next. Any other questions on how this? What is this about? Yeah. Yeah. That is also going on here. So this test is running inside Chromium. So it starts a headless version of Chromium. So it's a real browser. And I can actually just run it again to see how fast it is, because now it doesn't need to bundle. And it's only one test, but I'm going to show you the speed again later. This is very fast. And running headless Chrome is not fragile. It's not like it's sometimes crashing or sometimes slow or something. Headless Chromium is just as fast as JSDOM. So this is just a nicer browser. All right, let me continue a little bit. So we get nice error messages here. So it will say something about installing types, save dev type Mocha. And then we need to add Mocha to the types field in tsconfig. So let's try to do that. So npm add save dev types Mocha. Be quick. And we will look into tsconfig. For those of you who don't use TypeScript, TypeScript has its own configuration file where you can specify a lot of things. And apparently we need to specify that it should make default available the Mocha types. So when we did that, now we don't have the red squiggles anymore. So now it looks nice. Let's also just verify that. Okay. Let's just verify that we can still run the test. Then writing your own assertions is not really nice. So one of the difference between Mocha and Jest is that Jest is everything in the kitchen sink. So it has a module bundler, it has a test runner, it has also a lot of assertions and a mocking tool, and everything is in there, which is nice for some people. I like this philosophy of small tools better. And with Mocha, it's a little bit more like that, because the assertions comes from you can use assertions from other libraries. And one of my favorites is called Chai. So we will just use Chai here. So let's add as a developer dependency, Chai, and the types for Chai. And then go back to our test and remove this one. So we don't have the assert equal anymore. But now we would like to say expect, which is not really, I need to import that. Really hard to type when you are doing demos. Expect. So instead of assert equal, I can say expect that calling this function should give me a value that is equal to this value. This one. So this uses the standard assertion library from Chai, and if I run my tests, they need to bundle again. So did you see that pre-bundling step? So let's talk a little bit about pre-bundling. I don't think you remember if you did that. So one of the reasons you get speed from Vite is that it will look at your package JSON and look at your imported dependencies and see if what modules are you actually using in your tool. And then it creates a single bundle, or maybe a few, I'm not sure, but that is like pre-packaged for loading automatically. And if there are no changes to your package JSON, it can just reuse the bundle from the last time around. So now I added a new dependency, which is Chai. So it detected that automatically and automatically built the bundle again. And the next time I run the test, it doesn't need to do pre-bundling anymore. So it's just a nice little cache that is useful to have. So now we have better assertions. An interesting thing to look at would be what how does it look like when the test is failing? So let me introduce an error into the code. So I will be an evil developer and change this code so it doesn't work anymore, and run the test. And I would also like to try something because it's live demoing. So let's also say CI broke message if this fails. So now you get an error message from Chai, which tells you just like with Jest. So we expected this value, HTTPS, but we got this value. So our code is broken. This test catched a bug. And if we ran this on continuous integration, it will automatically signal to the CI server that the test was failing, so the build will be broken. So that is nice. Let me just fix it again. We don't have broken code. So now it's not broken anymore. I have two more things I want to show you: debugging and code coverage, and three things, and speed. Any questions at this point before I continue? Yes? That is a great question because I can answer yes to that. If I understand the question correctly, it was if you can pass in extra configuration options to Puppeteer so that you can turn on individual settings. And if we just look at the website for Mocha-Vite Puppeteer, there is something called advanced configuration. So in there you can specify command line options, and we're going to do that in a second. You can also add a config file, a JSON config file, and in there you can mention specific options to both Puppeteer and other tools that we build on top of. So yes, that's something you can do. Other questions this far? Yes, Vasil?
Yeah. So have you tried actually to just extract the assertions from Jest and use them instead of?
That's also a great question. So why am I using Mocha? Why am I not just using some subset of Jest? And it turns out that Jest is actually in the middle of a process of extracting something called Jest Core, which is not currently available as something you can use, but will be just the core thing. So you don't also get the bundler and also get, so you can like pick the parts of Jest that you want to use. So when they're done with that in half a year or something, I would really love to create a Jest Vite Puppeteer tool that does exactly the same thing as this one, but just uses the public Jest API instead. Because then you could use the same assertions and the same syntax for describe and it, etc. Yeah, yeah. Yes. But unfortunately, it's not really possible. I mean, I could do it with whatever is their current status, but it's not supported at all, so that their API will change, and I don't want to do that. All right. So what if your test is misbehaving and you cannot figure out why? Using console.log statement, you might want to look at your running test in a debugger. So let's try and see how to do that. So you can break into the debugger by writing debugger, but you also need to have the debugger attached. And you can, I should save. And you can do that by passing in the debug option to Mocha-Vite Puppeteer, which will still start Chromium, but now in a version that is not headless, but opens up a and I can almost not see anything here. So this is a default profile of Chrome, so it's very small. So let me just actually, this should be here. And it should have shown me where in the code I am. This is what demos are like. Something, it doesn't exactly do what you think it should do. So if I step into this, yeah. So so now you are running your tests and your code inside Chrome, and you can use standard Chrome debugger features here. So I can step into code. This is what I just did. I can step some more. Now I'm in the test, but I can step into this get repository URL. So now we are inside get. Oh, this is very small, tiny to see. I can probably zoom in. So we are now in this function, and we can continue debugging. We can look at the values of variables here, and all the debugger features are available. So you can easily have more advanced debugging than just doing console.log. So that was debugging, and I also want to show you about code coverage. So now I just wrote a single test for this very, very big application. So how much code did I really cover with this single test? And you can pass in the coverage option to Vite Puppeteer, which will run your tests again, this time instrumented to capture or measure the code coverage. And it doesn't really tell you anything. That's because, let me just show you that this produced a new file folder here in the file system with something called NYC output. And NYC is the same coverage tool that Jest is using. NYC comes with their own reporters and stuff, so I didn't want to bundle that into Vite Puppeteer. Small tools again. One tool has each their purpose, and so to get actual output from NYC, we need to run an NYC reporter here. So you can do that by doing pnpm add NYC. It should be quick, and then you can do NYC report. It will now tell you that we did some coverage of the utils TS function. Actually, 54% of the statements in there is now covered by tests. That's awesome. But which statements? We can see that over here, but that's not readable at all. So there's other types of reporters built into NYC. This has nothing to do with Vite Puppeteer, but having small tools, you get the power of the other tools you combine with. So this has an HTML reporter built into it. So what did that do? That created a coverage folder. So I can open up coverage index HTML, which will give me this 55% of the files in here, which is only utils TS for now. And I can actually get this fine listing, just like you can with Jest and other tools, where you can see that we are now actually covering this line of code because this is what we decided to test, but we are not covering these other branches of this if statement because we didn't add test for that. So if we are trying to get good coverage, we can easily see what kind of test cases are we missing, and we can easily add those. That's everything that Vite Puppeteer can do today. I wanted to show you also that it's fast. So I have two projects that I have done this thing that Vasil talked about. So I had this project built with Create React App, which uses Jest and uses Webpack and uses TypeScript. And it tests various things, but it also has a test suite with 100 artificially created components and 100 tests that test that those components work correctly. So there are 100 different components in 100 different source files, and then 100 different test files next to them. So it's just an artificial performance test, but I can run this with Jest over here in the old project. And I'll be using time to measure how long it takes. And this is familiar output from you guys who have been using Jest before. So it runs through all these components, and you can see how fast it is. It runs 42, 49, 56, 63, 70, 77, 84, 91, and we're done. 20 seconds to run tests for 100 components. And then I have the same thing for actually built into the source code for Vite Puppeteer. I have a performance test in there. And it's the same component repeated 100 times and a test, and it's TSX file. Sorry, it's TypeScript. So it's exactly the same scenario. And if we run the tests here, you can see how fast it is. So it will run all components, and we're done. 8 seconds. Vite is fast. That's all I have to say. Time for questions. Yes.
Now you're testing like a utility function.
True. Not in this performance test.
No,
yes.
Or, yeah.
But the other case, yeah.
Are you also meant to use this for testing like components?
Yes. So for example, let me just show you the component. The component that goes into this performance test is just a simple React component, which will render this type of code. So it has greeting, and you can enter a name, and you can have a submit button. This is standard React code. And the test for that is looking like this. So here I'm using something called testing library, which is a popular testing library for testing React components and HTML in general. And as you can see here, what we do is we render this component. Then we expect it to say hello. Then we type in some random name. So each of these 100 tests are different. We wanted to make sure that it's somewhat realistic. And then I have the test type in this name that was just written so I type in this random name into the HTML page, and then I finally expect that the page was updated because of the change handler and because of the set value thing here, it would re-render with the name that I just typed. So all this is included in a single test of this single component. This is a fairly standard way of testing components in React. And this works out of the box with Vite and with Mocha Vite Puppeteer, and is faster. Yes, it's the same test in both scenarios. Good question. Other questions?
What
yep.
your experience with the Webpack? You said that you started using Webpack.
Webpack?
Yeah, in the setup instead of using Vite.
Yeah, I mean, that was like 2 years ago or 3 years ago when I started this first project where I used Jest. So that was like what was available at that time. So that was I just bootstrapped this project with Create React app 2 years ago when I created it. So it was just interesting to me to compare the speed of exactly the same project by building it exactly the same way in Vite, and then comparing speed like this. Yes, question? Yeah.
So why is it faster? Is it because of Vite? So you're not using the Jest kind of one-person stuff? Is that it? Or?
That's mostly it. So Jest has a way of, I mean, Jest is basically built with the same kind of state-of-the-art 3 years ago for creating bundlers. So they are I don't know how their bundler works in detail, but I guess it's inspired by Webpack. So by doing that, they kind of got stuck 2 or 3 years ago. So the way Vite can be this fast in dev server mode is because it's not really doing any bundling. It's just letting the browser fetch resources directly from the file system. So it bypasses a lot of logic that Jest has to do that Vite doesn't have to do. So and that's the best way of doing optimization. That is to stop doing things that takes time. And that's basically how Vite gets its speed. Yeah, question?
So I suppose if you wanted to have any of it,
Yes, so this uses Mocha out of the box. So if Mocha has a similar feature, or a plugin, or a reporter, then it mostly should just work. There are, since the integration of running Mocha inside a real browser is a little bit more tricky, there are some things that doesn't work out of the box. And one of the things that is on my wish list is to create a watch mode. So right now, Jest can watch where you only run a single test that was changed by the changes you made, which is nice because Jest is slow, so it's nice to be able to run just a subset of your tests. But if you had hundreds or thousands of tests for your Vite project, you might want something similar with Mocha Vite Puppeteer. And I would like to build such a watch step, and it's not just a matter of adding some plugin. It's actual work that has to be put into that. So, but for many other things like reporters, for example, most of the standard mocap reporters are just supported by out of the box. Yeah. Other questions? I guess that's it then. Thank you so much.